Good morning, everyone. So, hello. This is going to be a quick run through of our thesis, and this is presented by me, Joe Catarata, and my other members have prepared this presentation as well. So, these are Charles Chong, Ralph Guansing, and Patricia, Caro. So, for our general objective this thesis, we aim to develop a bandwidth management solution for group-based wireless devices in a software-defined network environment. Specifically, our objectives are to develop and design a bandwidth management solution for group-based wireless devices in a software-defined network. And we must evaluate and verify the performance of these algorithms through the use of a network simulation tool. So, we also need to evaluate the effectiveness and feasibility of this solution in a small-scale network environment. This small-scale network environment is to be simulated using Mininet. So for our system implementation, it will consist of a network topology, which of course includes the network controller, which is going to be Rio, and the network controller is connected to an Ethernet switch. This switch is connected to 3 SDN routers, namely the Zodiac WX. So 2 of the SDN routers have nodes from each group connected to them. Meanwhile, the third SDN router only has the group 1 connected to them. So this consists of node A and node B, and both of them are included in group 1. So as stated earlier in the system implementation network topology, the Rio controller is necessary because it is used to send the rules and flows to each router. We will also use the Rio controller to send out our bandwidth management application, and this uses the MAC address of each device and associates them with their respective group and bandwidth. So for our bandwidth prioritization configuration, the total bandwidth is set to be 10 Mbps. Group 1 will get 2 Mbps max, Group 2 3 Mbps max, and Group 3 will have 5 Mbps max. So for reconfiguring the device group settings, we store it in a CSV file. This is a comma separated value file, which can be managed through a user interface for convenience. It allows the administrator to add devices or edit configurations or groupings. So for a device joining or leaving, the process will be that whenever it enters the network, the controller checks the MAC address of that device through the packet being received by it. Afterwards, the controller correlates the MAC address of the newly joined device to a group. After successfully being associated to a group, that device will now follow the bandwidth limitation of that said group. So this is a sample result from a simple experiment that we made. So we did a simple test from node A, node B, and C, and these nodes are assigned to each different group. So we did the simple speed test, and we discovered that after 10 trials, right, the average bandwidth of each group is near the said settings for each group. So for node A, we get 2.145 Mbps, and their setting is 2 Mbps. For node B, we're getting 2.918 Mbps, and their setting is 3. For node C, the setting is 5 Mbps, and they are getting 4.376 Mbps. So my colleague, Ralph Guansing, will be talking about the hardware that we use and other details that are significant to our experiments.
The wireless feature of our SDN implementation would not be possible without the use of the Zodiac WX by northbound networks. It utilizes Open vSwitch and OpenWRT for SDN and wireless features respectively. The SDN AP also supports meters, which makes bandwidth limiting possible. The SDN-capable access point works with any standard OpenFlow capable controllers and requires no modifications as it looks to the controller like a standard OpenFlow switch.